What's up, guys? We're rolling here. At this time on 3D NerdStop, we're going to build a CR-10 3D printer. We're going to set it up in CURA, and we're going to do some test prints. Alright guys, here we go. This is our CR-10. I'm doing an unboxing real quick. This thing was real easy to put together. It didn't take that long. I'd say about 30-35 minutes to put it together total. And that was mostly because I was videotaping it. If I just would have been putting it together, I probably would have had it together in 5 or 10 minutes. It's really not difficult. Now, the first mistake I did make here is I went ahead and put the Z-axis on and put the little T-brackets on the two sides first before lining up the holes underneath. Which you put the bolts in, which was a mistake, because you'll notice I took the T-brackets back off here real quick, and then I lined the holes up and put the bolts in through the bottom. And once I do that, it goes together real easy. So that's what you need to make sure you do first. It's really simple to put together. You put the bolts in through the bottom, you put the T-brackets on the sides, you hook up the Bowden tube and then plug in all your wiring. The stepper motors are nicely marked. There's a limit switch on next to each stepper motor, and the wires plug into the stepper motor and the limit switch. And it's real easy to do. It takes no time at all. So then I turned it on and tested it out, and all the accesses seemed to move just fine. So that was great. So that's pretty much that. So let's jump over to the computer real quick and install CURA with this for setup. Alright guys, so you open up CURA, and then the first thing you need to do is go up on the menus, up in the menu bars, go to Machine, and then you want to go to Add New Machine. Now as you can see in my list, I have my Robo 3D R1 listed, and I already have the CR-10 listed because I've already added it once to figure out how to set it up. So we're just going to add it again, no big deal. So what I did is I went to Add New Machine, and when you click on that, it'll bring up this Add New Machine wizard. No big deal. Next thing you do is you click Next. Okay, and then after you click Next, you want to go down to Other. Alright, because you don't need to select any of the ones that are listed. You can just go down to Other. It's real simple. Okay, then once you get to the Other screen, you click Next. You go to, after Other, you want to go down to Custom. Alright, once you click in Custom, in here you're going to name the machine, CR-10. You're going to give the dimensions. It has X dimension of 300, a Y dimension of 300, and a Z dimension of 400. The nozzle size is 0.4, and it does have a heated bed. Okay, so then you click Finished. And there you go, it's added. As you can see here, it sets all the defaults for you. This is just based on a generic 3D printer. So what it does, it sets the layer height to 0.1, the shell thickness to 0.8, the top and bottom thickness to 0.6, the fill density to 20%, the print speed to 50, the print temperature to 210, and the bed temperature to 70. It doesn't have any support material or platform or all that. Now it does have the filament dimension set to 2.85, which is not correct. So we will need to change that. Okay, so the things I changed on mine is I changed the layer height to 0.2. I changed my shell thickness, which y'all have seen on almost all my prints. I do it at 1.2. I do my top and bottom at 1.2. And the reason I do those dimensions is I feel it gives the prints the best structure I can get out of them without putting too much material into it. It makes them rather strong. It makes them fairly sturdy. Fill density of 20%. I left the print speed at 50. I did drop the print temperature down to 200 because the filament I use, the inland filament, prints really well at 200. I did drop the bed temperature to 50 because it sticks best between 50 and 60 C. I haven't done anything with the support material or the platform adhesion type. I changed the dimension of the filament to 1.75. And other than that, I left the flow at 100% and I left the nozzle at 0.4. So then we're going to go into Advanced. And this is the defaults it comes up with. Is the speed for the retraction at 40 and the distance 4.5. The layer thickness is 0, which is fine. If yours says different, I think I might have changed this one by accident before I recorded this. I think it might come up at 0.1, but I changed it to 0 because I want it to be the same. If you set it to 0, it's the same as whatever your layer thickness is. So if your layer thickness is 0.2, then it makes your initial layer 0.2 if you set it to 0. I want the initial layer width at 100%. The cut off the bottom, I'm not cutting anything off the bottom normally. That's not something we worry about. The travel speed, we'll get down to speed. For travel speed, I have it at 150. Bottom layer speed is by default 20, and the rest are all set to 0, so they print whatever you set it on the original page. The cooldown, or the cooling, minimum layer time is 5 seconds, and so on. So if we go under cooling, this is one of the things I change. Is originally it's set to 0.2. So it basically has the fan on all the time. It starts off with the fan on, and I don't like the fan on to start with. I like my first layer to not have the fan, especially with PLA. So I set it to 0.4, so the first layer at 0.2 won't have a fan, and after that it'll print with a fan. Okay, I leave the fan speeds at 100%. I did change the minimum speed to 10. And cooling head lift, no, I don't check that, so I left that alone. Alright, so then we're going to jump over to the start and end Z code. I did not change this stuff here. I left it as is. I ran a print, and this Z code works just fine, just as it is. So you don't have to worry about changing the start or the end Z code. It does work as it is. So you don't have to worry about that. Okay, so I dropped a 20 by 20 cube on here. So it's a 20 millimeter by 20 millimeter cube, so you can see the build volume in CURA. Now, you know CURA shows you the max build volume you have based on your dimensions, so you can see how big the build volume is based on that 20 by 20 cube. Okay, so let's set up a test print here. First thing we're going to do is we are going to print the calibration cube. It's a XYZ 20 millimeter calibration cube. I'll have a link in the description for all these things in Thingiverse I'm about to show you. So we would get that and download it. We're also going to do our torture test. And we're also going to do an overhang test. This is a new one I found. It looks like it's fairly interesting, so we'll see how it prints. And then we're also going to do our benchy, which we usually do to test out a printer, so we can see how well the printer prints the benchy. Because this has a lot of all the elements that you find in a model to print. Okay, so here we go. I'm just going to set all 4 of these prints up because this has a big build plate. All 4 of them up at once on the build plate. So we are going to print with a layer height of 0.2, a shell thickness of 1.2, a top and bottom thickness of 1.2, fill density of 20, a print speed of 50, a print temperature of 200, and a bed temperature of 200. We're not going to do any support material. We're not going to do any platform adhesion type. Okay. This says it's going to take 3 hours and 57 minutes, so 4 hours. It says it's 15.91 meters of material, which is 47 grams of material to print all of this. Alright, so we'd save this off to an SD card, get the printer heated up, and get her printing. Alright guys, one more thing before we actually jump over to the printer to show the printing. I jumped over to the printer. I want to show you, the first time I put an SD card in here, it took me a while to figure out how to actually get it to load the SD card, because it didn't load it as soon as I put it in. I apologize for the quality of these pictures. It's hard to take a picture of the LCD screen. It's a little hard to get it to come out well, but so I did the best I could. But here's what we've got. This is the LCD screen when it first fires up. Okay, so then you'd push the button and go into it, and then it gives you your menu here. And as you can see, it says no card inserted. Now I actually have the card inserted at this point in time. It's in the side of the machine, but it says it doesn't have a card. So you have prepare, control, no card, and then you have this int it SD card. Okay, so if you go down to the int it SD card and tell it to select it, it will load the SD card then. So you have to tell it when you put an SD card in it that you want to load that SD card. And it does that. You also have the same thing if you have one loaded and then you take it out and put a different one in to do another print. You have to tell it you want to change the SD card. If it says there's already one in there, like if you turn it off and change the card and put the card back in, and you boot it back up and it says there's an SD card in there, you're best to come down here and hit this change SD card before you try and print. I found that if you didn't, sometimes it would have the new files, sometimes it would still list the old files. So I just found it best to always come down here and hit the change SD card. Okay? Okay guys, here we go. It's done printing, and this is it on the print bed. As you can see, I had a little bit of a stringing problem here. I'll explain why that happened in a minute, but I did have a little bit of a stringing problem here. Other than that, you can see that everything looks pretty good. It seems to have printed all of the pieces. Doesn't seem to be too much of a failure, but we'll go through each piece individually. Okay, so here we are. This is the cube, which is the 20 by 20 cube, X, Y, and Z. It looks pretty good, but the big question is when we do put a calipers on it, what dimensions do we get? Okay, so here we are on, if I'm not mistaken, this is the X axis. And as you can see, it's kind of hard to read. It says 20.19, 20 millimeters, 0.19. So that's pretty good. I say anything usually within 0.2. Because you do have expanding and contracting of the plastic. I can probably calibrate this to get it a little closer to 0.1, but for right now I'm not going to worry about it. To me, that's about as close as my Robo shows up printing this one too, so I'm going to leave it as is for right now and see if it becomes an issue later. So on the X-axis, it seems to be pretty good. Then you have the Y-axis here. As you can see, it's 20.18. So it's almost the same as the X. So that tells me that the X and Y are printing the same, printing on the same calibration. Okay, so then we jump over to the Z. And as you can see, the Z-axis came up at 19.51. So they're missing a half a millimeter here. That's not good calibration. I would prefer it to be within 0.1, if not 0.2 of a millimeter, not 0.5. That's missing a half a millimeter. That's actually quite a bit missing. So we'll have to look into the calibration on the Z-axis, but let's run through the other models real quick, and then we'll come back to this. Okay, so here we go. Here's the torture test. Other than the stringing, you can see that the cube looks pretty good. The different thickness walls look okay. If you look at the towers, now the biggest point of these towers is supposed to be stringing the 9 little spikes here. So it's really hard to tell. I mean, the print of the towers themselves is really hard to tell in this photo are actually really nice, other than all the stringing between them. And I'll explain why there's so much stringing in just a minute. If you do look at the holes in the bottom down here, they look really nice. They're actually the way they're supposed to be. They look exactly as they're supposed to. You can see for the bridging here, the overhang part here, it did have a failure at one point. But that's pretty normal for even the Robo fails around that point. So I wasn't too surprised about that. It did do a really nice job on the little arm that sticks out here across the bottom. That's like 0.1 millimeters in thickness, and it printed it really nice. I mean, I'm not sure what the thickness is supposed to be, but that printed out really nice. And it's there and it stayed, where on the Robo, when I actually tried to take the print off, that was so thin it broke right off. So this came out okay. Let's jump over to the overhang. Here's the overhang from the side. As you can see, again, we have a stringing problem, which we're aware of. But if you kind of try and ignore the stringing problem, you can read all the numbers all the way up. If we lay it on its side, you can see here as it goes up and around that we hit roughly about, I would say 20 to 25, somewhere in there, before you start really seeing the stringing across the bottom here. So that does pretty good, and even when it goes all the way up to 5 degrees for the stringing isn't bad. You can still see that it managed to print the majority of it with just a little bit of stringing on the bottom, to where if you actually had that, you could clean that off with sandpaper and the piece would still be usable. So that came out pretty good. So then we'll jump over to the benchy here. Now I'll admit, this benchy, if you ignore the stringing issue, came out really well. I mean, it really did. You can look in the upper right hand corner, or upper left hand corner here, and see the doorway looks really good. There's a little bit of goofiness in the top of the doorway, but not bad. You look in the one in the middle at the top at the square window. The top of the window has a little sag to it, but it's just a tiny little sag. I mean, that really did really good bridging across there. You look at the other one across the top on the right, the brown porthole on the back looks pretty good. It's a little messed up in the top, but it actually looks pretty good. If you go to the lower left-hand corner, that one looks really good. I'm mostly worried about the bow of the ship here, the front, and the porthole in the front of it. That looks really good. It's really smooth. There's no real heat problems or anything. The cooling was nicely done. The speed was good for it. It's nice and smooth. If you look at the top here and the middle one on the bottom, the top came out fairly nice. The smokestack came out nice. The live bait box, I guess is what it's supposed to be on the benchy, came out nice. And the flagpole hole in the back came out fairly nice. Now, as you can see on the bottom here, the name benchy, or it should be written across the bottom, did not come out at all. And I think that has part of the problem to do with why the Z-axis was wrong on the cube. So in order to test that, what we're going to do... Okay, guys, so what we're going to do here is I'm going to take the same 20 by 20 millimeter cube, and I'm actually going to make it in 4 different sizes. So I'm going to reduce it down to a 10 by 10. Then I'm going to have the 20 by 20. Then I'm going to do a 30 by 30 and a 40 by 40. And what I'm trying to test here is if the Z-axis is basically off by the same thing all the way across, basically, then that tells me that it's the nozzle height from the bed on the first layer is off, which means I'm leveling the bed incorrectly. If it's off by a different amount from the first one to the last one, the percentage off gets a lot bigger as the object gets bigger, then that tells me it's a calibration problem in the software because it's not printing the layers correctly percentage-wise. So that's what I'm trying to figure out what it is. So we'll take a look and print all this and see how all that comes out. Okay, I'm doing all the print settings on this the same as we did the last set. This says it's going to take 3 hours and 20 minutes, which is 15.89 meters of material and 47 grams. Now, we did have a stringing problem last time, which when I come over here to advanced, I don't know how I did this, but somehow I accidentally, on the retraction, changed it from 4.5 millimeters to 0.5 millimeters, which is why we had all that stringing, because I accidentally changed my retraction dimensions the last time I ran the print. So we're going to change that real quick. I'm going to change that to a speed of 50 and change it to a distance of 4. So hopefully this will get rid of all the stringing. Okay? So we're going to save this off to the SD card, take it over to the printer, get the printer heated up, and get her printing. Alright guys, so here's the prints on the bed. As you can see, the stringing problem is pretty much gone. There's a little bit of stringing on the small cube, but the other ones there's really no stringing between them, which is what we were looking for, so we're not running big strings across like we had before. So we'll just jump over to the calipers here real quick. Now we're on the 10 by 10 cube, and as you can see, the 10 by 10 cube came out to be 9.69. It's still roughly off by a half a millimeter. When we go to the big one, which is the 40 millimeter, you can see we are off by half a millimeter. Now that could just be the difference between those two is because one side of the bed was a little higher than the other one. Again, I'm learning how to level this bed, so I'm not real good at it right now. It's going to take practice. Eventually I'll have it down to where I know, okay, yeah, that's level, it feels correct, whatever, because I'll have done it enough times. So this tells me that that the problem is, because of the distance on these two models, is my initial layer height is incorrect somehow. So let's try to do one more experiment real quick in this video. And just so you know here, this is the original cube here, which was 19.5. So you can see that between the 20 and the 40, it's the exact same distance. So that tells me that it is the bed leveling issue. Okay, so what we're going to do is I'm going to print another cube. All the same settings we've gone before. I am going to speed the print speed up a little bit. I'm going to speed it up to 60 millimeters per second because I think I can go a little faster than 50. This one little cube is going to take 19 minutes. It's 1.66 meters of material, or 5 grams. Okay, so we're going to do it this way, and I'm actually... What I have been doing is doing the space between the nozzle and the bed with a sheet of printer paper. Okay, so what I'm going to try this time, because that seems to be too small of a gap, is I'm going to use a business card to do the gap on this one. Okay, now what I'm also going to do is I'm going to come over here and print it again, but I'm going to print it on a raft. And when I print it on the raft, I'm still going to use the printer sheet of paper. Okay, because that way the first layer doesn't matter, because it'll print the raft and then it'll start printing the z-axis from the top of the raft. So therefore the z-axis then should be correct. So that's what we're going to try. We're going to try both of those. One with a business card and one with a sheet of paper. So we would save this off to an SD card, take it over to the printer, get the printer heated up, and get her printing. I'm not going to show the printing of these two. You've seen it print. We don't need to show that again right now. So here we go. These are the two prints. And as you can see, the X, which is the one on the left, is the one where I did it with a business card. And the Y is the one where I printed on a raft. It's kind of hard to see in this picture, but you can see the one with the business card. The print is a little rougher on the bottom than the one that was on the raft. Okay. The X one, the one on the left, was barely stuck to the build plate, but it was stuck to it. And the Y was stuck pretty good, but the raft peeled right off. The raft came off beautifully. Okay, so we jump over to the calipers. Now this is the one that I used the business card to space, and as you can see, it came out to 20.08 millimeters, which is basically perfect. Based on that, that tells me that it needs to be closer to a business card thickness than a sheet of printer paper thickness to get the z-axis correct. Okay, but when I printed on a raft, excuse me, it came out to 20.02, and the raft was stuck better. So what this tells me is, doing this manually leveling, I'm probably better off printing all of my prints on a raft. Yeah, it uses a little more plastic to do that, but then I'm going to get my z-axis correct all the time, or at least it should be closer to correct all the time, and I don't have to worry about having the nozzle spaced perfectly every time I go to print. As long as the bed is basically level, the print should come out beautifully because it's sitting on top of that raft. And if this was a big complicated print, when I used the business card, I'm pretty sure the print would have broken free from the bed. The fact that it was just a little itty bitty cube, it didn't manage to, but like I say, once it got done and I went to take it off, I just barely touched it and the thing popped right off. Where the one on the raft, I actually had to use the scraper to get it off the bed. So I think using a raft underneath the print is a better option than using the business card thickness in this case. Thank y'all for watching. If you like what you saw, please like and subscribe. Please leave a comment down below. I'd love to hear from you. You can also check out my Patreon page. $1 a month goes a long way into helping out the channel. If you don't like Patreon to make a donation, there'll be a link in the description down below to PayPal. You can make a donation through them. It's not required. It's completely optional. It's up to you whether or not you'd like to make a donation. All my videos will always be posted on YouTube for free to my viewers. So until next time, y'all have a great day.